Good morning, student. I am Mr. Vinod Thomre and we are studying plant physiology. The next topic from plant physiology is properties of water. Now, first of all, see the physical properties of water. Water is the chemical substance with chemical formula H2O. One molecule of water has two hydrogen atoms covalently bonded to a single oxygen atom. Water is generally a tasteless, odorless liquid at ambient temperature and pressure. Okay, in its pure form, water do not has a taste and a odor. Liquid water has weak absorption band at wavelength of around 650 nanometer, which causes it to appear to have a blue color. Under standard conditions, water is primarily a liquid, unlike other analogous hydrides of oxygen family, which are generally gaseous in the form. This unique property of water is due to the hydrogen bonding. Now, water is water is found in three different forms. That is, the liquid form is called water, the solid form is called ice, and the gaseous form, which is called vapors or water vapors. Within the Earth's atmosphere and surface, the liquid phase is the most common and is form that is generally denoted by the word water. That is the liquid form of water. The solid phase of water is known as ice and commonly takes the structure of hard amalgamated crystals such as ice cubes or loosely accumulated granule crystals like snow. The gaseous phase of water is known as water vapor or the steams. The next property is heat capacity and heat of vaporization and fusion. In case of water, water has a very high specific heat capacity of 4.1814 joule per gram into Kelvin at 25 degrees Celsius, the second highest among all the heteroatomic species. The specific enthalpy of fusion of water is 333.55 kilojoule per kilogram at 0 degrees Celsius. The same amount of energy is required to melt ice as to warm ice from minus 160 degrees Celsius up to its melting point, or to heat the same amount of water by about 80 degrees Celsius. The specific heat capacity of ice at minus 10 degrees Celsius is 2.03 joule per gram per Kelvin, and the heat capacity of steam at 100 degrees Celsius is 2.08 joule per gram into Kelvin. Then the next property of the physical property of water is water density and ice. The density of water is about 1 gram per cubic centimeter. The melting point of ice is 0 degrees Celsius at standard pressure. Cohesion and adhesion. Water molecules stay close to each other, which is called generally cohesion. The attraction between similar molecule, we call it as a cohesive force due to the collective action of hydrogen bond between water molecules. Water also has high adhesion property because of its polar nature. On extremely clean smooth glass, the water may form a thin film because the molecular force between glass and water molecules are stronger than the cohesive force, which call them as a adhesive force, the force of attraction between two different molecules. In biological cells and organelles, water is a contact with membrane, water in contact with membrane and protein surfaces that are hydrophilic, that is surfaces that have a strong attraction to water. Then water also has a surface tension. Water has a and usually high surface tension of 7.199 mn per m at 25 degrees Celsius, which is caused by the strength of hydrogen bonding between water molecules. This allows insect to walk on water. Then the next property of water is the capillary action. Because water has a strong cohesive and adhesive forces, it exhibits capillary action. Strong cohesion from hydrogen bonding and adhesion allows tree to transport water from more than 100 meters upwards. Then water also acts as a solvent. Water is an excellent solvent due to its high dielectric constant. Then the next property of water is polarity and hydrogen bonding. An important feature of water is its polar nature. The structure has a bent molecular geometry. For the two hydrogen from the oxygen vertex, the oxygen atoms also has the two lone pair of electrons, and that forms the two poles, that is the side of oxygen called negative pole and the side of hydrogen is called positive pole. Then the chemical properties of water. Water reacts with a lot of substances to form different compounds. Some significant reactions are as follows. Amphoteric nature, that means water can act as both acid and base, which means that it is amphoteric in nature. If you see the example, water behaves like acid also and base also. Here acidic behavior, water when react with ammonia to give hydride ion and ammonium ion. Here it play a role of acid, where in basic behavior when water combines with hydrogen sulfide, then it gives hydronium ion plus Hs minus ion. Then the next chemical property of water is redox reaction. Electropositive element reduce water to hydrogen molecule. Thus water is a great source of hydrogen. Let us see an example in this case. Two water molecules when combined with two sodium molecules, it will give two sodium hydroxide molecules plus H2 as a gaseous form. During the process of photosynthesis, water is oxidized to oxygen. As water can be oxidized and reduced, it is very useful in redox reaction. The next property is hydrolysis reaction. Water shows hydrolysis reaction. Water has a very strong hydrating tendency due to its dielectric constant. It dissolves many ionic compounds. Some covalent and ionic compounds can be hydrolyzed in water. Thank you.